Okay, let's dive right into this. Welcome to today's explainer. We're going to be tearing down a piece of equipment that just works tirelessly in the background for us, the pool pump. But we aren't just looking at how it works. We're actually going to look at how it fails, and then, step by step, figure out exactly how to upgrade and revive it.
So what happens when bad chemistry actually attacks heavy machinery? It's a fantastic question to start with. Because, before we even talk about spinning motors or leaking water, we really need to set the stage for the mystery here. What happens when the very water this heavy machinery is designed to move turns against it? Keep that in mind because we're going to meet the true villain of this story very shortly.
Our source material today comes from the pool guy, ML, who rolls up to a job and finds an absolute classic problem: a leak. And not just any leak either. This is happening in the most usual yet critical place, the pump seal. Water is escaping exactly where it shouldn't be. Now, to safely address this, we absolutely have to isolate the pump. The crucial first step? Turning off the power, of course. But we can't just stop there. As our source points out, this particular pump sits dangerously below the pool's water level. If we just cracked it open right now, gravity would send the entire pool rushing straight into our workspace. No thanks. So we've got to close the valve, shut everything off, and carefully loosen the unions to completely isolate the machinery.
All right, now that we've disconnected it from the pool's plumbing, it's time to relocate. Popping the lid off and physically moving the pump outside makes it just remarkably easier to work on. We're essentially taking our patient from a cramped, dark equipment pad and shifting it right to a bright workbench where we finally have the space to see what's going wrong.
Now, what's really interesting about this setup is that to get to the root of our leak, we can't just pop off a single cover. We actually have a clear roadmap of internal layers to methodically tear down. We've got to get past the diffuser, pull off the impeller, and finally detach the seal plate. It's a journey straight into the core of the machine.
And let me tell you, that journey requires some actual physical effort. To get inside, we first have to undo this band running right around the middle of the casing. But as the source notes, because it's been sitting on there for a good long while, it can be incredibly tight. You actually have to carefully pry that band off. But once that's done, you can quite literally split the entire pump in half, exposing the internal mechanics.
Okay, pump is split open, so we're really drilling down now. First up, we tackle the diffuser by undoing all the nuts around its outside edge. That exposes the impeller sitting underneath. And here is just a fantastic mechanical trick from our source. The impeller is threaded on super tight. So, to untighten it, you wedge a flathead screwdriver right into the slot on the back of the motor shaft. Holding that shaft perfectly steady from the back allows you to just spin the impeller right off the front.
Boom! Once that impeller is off, we finally reveal the pump seal. And we really need to ground ourselves on exactly what a mechanical seal is doing here. It is literally the one critical barrier standing between the wet side of the pump and the dry electrical motor. Its entire job is to let that motor shaft spin thousands of times a minute without letting a single drop of water breach the motor housing. It's vital.
So, why did this vital barrier fail? Well, here is the crazy reveal straight from our source. The original seal relied on a copper cone, but looking at it right now, there's barely a little bit left at the bottom. Why? Because as the source states, it has just been eaten away by bad chemicals. That's our villain right there. Chemical imbalances in the pool turned the water corrosive, literally dissolving the metal core of the seal until the water broke through. To fix this mess, we have to extract every piece of that ruined part. And honestly, it isn't always easy. We start by undoing the 4 nuts holding the seal plate to the motor, loosening all 4 of them top to bottom. Then you pull the seal plate away. But to free the stubborn, damaged seal itself, you've got to get a little tactile. Our source notes, you often need to give it a sharp tap with a hammer to finally pop it out of place. With the old seal out, you can't just shove a new one in and call it a day. We have to prep for the transplant. After dealing with that highly corrosive water, the central shaft is looking a bit dodgy, so you've got to clean it up. Using a little wire brush or maybe some sandpaper, you carefully clear out all those little bits of debris and corrosion. We need the new part to have a perfectly clean surface to mount onto.
And this brilliantly illustrates how we're going to outsmart our chemical villain. Just look at the difference between the old part and the new upgrade. The old part relied heavily on that copper cone, which obviously proved totally vulnerable to being eaten away by pool chemicals. The new replacement? It's a shiny ceramic material. Absolutely zero copper to corrode. Plus, it features a much bigger O-ring to guarantee an incredibly tight, leak-proof fit. It is a direct upgrade built to handle bad chemistry.
Installing this upgraded mechanical seal is a very precise 2-part process. First, you take the white base part of the seal and push it firmly into place. Next, that shiny new ceramic piece goes right down on top of the white part. You've got to push them in together nice and tight. That tight ceramic-on-ceramic contact is exactly what's going to hold the water back while the shaft spins inside it.
Seal is seated. Now we begin the incredibly satisfying process of rebuilding our hardware. It's essentially just a reversal of our teardown. We put the seal plate back on and bolt it to the motor. Then, using that same flathead screwdriver trick in the back of the shaft to hold it steady, we tighten the impeller firmly back onto the front. Finally, the diffuser pops right back over the top of the impeller.
Okay, pause for a second because here is an absolute pro tip from our source. Grease your O-rings before you close everything up. It sounds like a minor detail, but honestly, applying a bit of pool lubricant to the O-rings helps tremendously when you're putting heavy machinery back together. It makes sure the rubber seats perfectly, it prevents pinching, and it creates a flawless watertight seal. Now for the final physical steps of reassembly. We bring the two halves of the pump casing back together and reattach that middle clamp band. And here's another great tactile trick. As you tighten the clamp, give it a little tap all around the outside. That tapping vibration literally shakes out any hidden slack in the band, making sure it clamps down uniformly. Once it's completely tight, we pick the pump up and place it right back into its spot on the equipment pad. Let's move to the pad and see how this builds back into the system. We reconnect the plumbing by tightening up those unions we loosened earlier. Then, we open up that skimmer valve. Remember how the pump being below water level was a massive danger earlier? Well, now it's actually our biggest advantage. Because it sits lower than the pool, simply opening the valve allows gravity to push the water right back in. It lets the pump effortlessly prime itself with water. We are literally in the home stretch now. The water is back in the casing, so we firmly stick the transparent lid right back on top. We make sure the system valves are set back to filter mode, and finally, the moment of truth, we flip the switch and turn the pump back on. The motor spins up, water flows right through the impeller, and most importantly, it flows right past our brand new ceramic seal.
And there we have it. A quick, close visual inspection confirms it. Absolutely no water escaping, no dripping down the motor plate. The leak is totally fixed. The heavy machinery has been successfully torn down, upgraded, and put right back to work. Job done.
But hey, as we wrap up today's explainer, I want to leave you with a bit of a provocative thought. We fixed the mechanical failure today, sure, but remember the villain that caused it? Bad chemicals eating away at copper. It really makes you wonder. Your pump might be running perfectly smoothly today, but if your pool chemistry is out of balance, what unseen components of your heavy machinery are those chemicals quietly eating away at right now? Thanks so much for joining me on this deep dive, and I'll catch you on the next explainer.